Hello, good afternoon, Algebra 2 Trig Honors students. So here's some of the formula that you need to know for the upcoming sequences and series tests. So we do have an arithmetic sequence. So it's written as a sub n equals a sub 1 plus n minus 1 quantity times the common difference. And then arithmetic series. So s sub n equals n over 2 times the quantity of a sub 1 plus a sub n. So once you need to find out the sum, you have to apply this formula. Geometric sequence. So a sub n equals a sub 1 times the common ratio to the power of n minus 1. And then the geometric series, so that is considered s sub n equals a sub 1 times 1 minus r to the power of n over 1 minus r. And for the infinite geometric series, so s sub n equals a sub 1 divided by 1 minus r. Okay, so now let's take a look at that, the simple questions. So for the first one, you want to find out the common difference first, and then the first 5 terms, and then the 52nd term, and then the explicit formula. So that means for the arithmetic sequence formula, you want to use that 5 consecutive times. So the first one, you want to apply that to find out the common difference. So for the higher term, you always want to use that as a sub n. So this one, the higher term is negative 234, so that equals negative 94. Plus n, well, the value of n is the number of terms from 19 to 39. Then that would be considered 20 terms plus 1, because you want to count the initial term. So then that would be 21 terms. So 21 minus 1, and then times the common difference. And then from here, you want to solve for d. And then once you find out d, you want to use the same formula. So you can find out a sub 1. And once you get a sub 1, you can get the rest of those 5 terms. And then finally, the explicit formula, you want to put it in back to the original formula. A sub n equals a sub 1 times plus n minus 1 times the common difference. So whatever that you have for the first part, finding d, the second part, a sub 1, so just plug in a number, and then you can find out the explicit formula. So for the one I'm showing you today, it's just a setup. Okay, so the rest of this, you need to solve that by yourself. Okay, so also you can check the word down the bottom of the page right here. And then for the next one, so this one is a geometric sequence. So again, the key word, the key phrase. So using that, a sub n equals a sub 1 times the common ratio to the power of n minus 1. So a sub n, so this one we want to use the higher term as the a sub n. Another way you can do it to find out common ratio, you can simply divide it. So 16 divided by 8, then that will give you the common ratio. So then that'll be what? 2. And then once you get the common ratio, so just find out a sub 1. So using that, the lower term as a sub n. So 8 equals a sub 1 times the common ratio, 2 to the power, n minus 1. So 4 minus 1. And then you just solve for a sub 1. So once you solve for a sub 1, you can find out a sub 12. Again, use the same formula to find a sub 12, and then use the same formula to find out the explicit formula. So evaluate the arithmetic series, describe. So for number 3, so would you know that's a sigma? So this one can be written as sigma I equals 1, and then minus sigma I equals 1 of 1. And then coefficient a can bring it to the front, and then the rest of this. So you just want to use the formula for this part. So this one right here is just like 1 times 11. So for the I, so keep that in mind, it's not the imaginary number. So that one is just like consider 11 times 11 plus 1 over 2. So using the formula, minus 11. And then finding the sum, so using that, the summation formula for the arithmetic series. So that one is considered n over 2 times a sub 1 plus a sub n. So everything's given already, so plug in a number, and then simply just evaluate it. So 24 plus 216. So find a sum. And then rewrite each series using sigma notation. So this one is the structure of 1/4 to the first power plus 1/4 to the second power plus 1/4 to the third power, plus 1/4 to the fourth power, plus 1/4 to the fifth power. So you want to find out the commonality. So you can set up the recursive formula. So sigma with k equals 1 to the fifth term. And the structure here is just like 1/4 to the power of k. And then number 6 and 7, evaluate each geometric series. So this one is just written as the structure of a sub n equals a sub 1 times the common ratio to the power of n minus 1. But in order to find out the sum, so we're using that a sub 1 times 1 minus r to the power of n over 1 minus r formula. So a sub 1, then that would be considered 1 coefficient here. And then common ratio, that's negative 2. And the value of n, which is the value of k, so then that would be 9. So this one is like 1 times the common ratio, 1 minus the common ratio, which is what, negative 2 to the power of 9. And then all over 1 minus negative 2. Okay, so and then the rest of this, evaluate. And then for number 7, it's quite similar. So the common ratio here, it's negative 2. So the way that I figured it out, it's like 2 divided by negative 1, the second term divided by the first term. And then a sub 1, obviously that's negative 1. So using the same formula, so it's negative 1 times 1 minus the common ratio, negative 2, to the power of n, which is 9 again, all over 1 minus the common ratio. Okay, so it's quite similar to this one here. And then for number 8, determine the number of n in each geometric series. So this one you want to find out what n is. So this one started with the sum, 341.25. So that equals 0.25 times the quantity of 1 minus 4 to the power of n over 1 minus 4. So this one I do recommend you to divide it first, divided by 0.25, or perhaps you might want to convert the decimal to fractions, and then you want to find out, try to isolate the base 4 right here, and then you can find the common base, so you can figure out the value of n. So once you simplified it, you'll see that it's one of the exponential equations, okay, and then you solve for n. Evaluate each infinite geometric series, describe. So infinite geometric series, we're using the formula a sub 1 over 1 minus r. So a sub 1 is given, common ratio is given, so everything else is pretty straightforward. So plug in a number, but you got to be careful, it's all a fraction. So it's 1 minus 1/5, and then the rest of that, evaluate. And this one here, a sub 1 is given already, common ratios. So 1/5 divided by 2/5. So in other words, like 1/5 times 5 over 2. So the common ratio would be what? 1/2. So again, using the same formula. So 2/5 divided by 1 minus 1/2. And then you'll get the sum. And 11 and 12. Determine the number of terms n in each geometric series. So this one, the sum is given already. We do know that's a geometric, so that means we're using this formula again. So sum of the geometric series, a sub 1 times 1 minus r to the power of n over 1 minus r. So the sum is given already, negative 104, a sub 1, which is what, 1? Because that's a missing coefficient, or the invisible coefficient. Common ratios, negative 5. Again, I is not the imaginary number, just a subscript number. So the value of I is just what? N. That's what we're looking for. So 1 minus common ratio, negative 5 to the power of n over 1 minus negative 5. Again, so once you simplified it, it's going to be one of the exponential equations, whether that's exponential growth or decay. So, and then you want to solve for n. And then this one, find a common ratio. We do know that's an infinite geometric series. Again, if that's infinite, so we're using the easy form of the summation formula. a sub 1 divided by 1 minus r. So 8, so that equals 0.8 divided by 1 minus r. And then from here, you want to solve for r. Okay? And let's see what else. That's it. And the rest of the solution here, once you find them, you can always check your work. Okay? So always check your work. Okay, so that's it. Thank you for watching the video today, and I'll see you guys next time.